Hello everyone. In previous lecture, we discussed some additional Linux commands. Such commands used for file compression, searching files, and managing disk usage. These commands help us perform different tasks efficiently in the Linux operating system. Today, we will move to another important concept in Linux, which is mounting and unmounting the file system in Linux storage device and also we discuss performance tools after mounting and unmounting. Firstly, you understand what is the meaning of mounting and unmounting. In Linux, storage device like hard disk, USB drives, and partitions can't be accessed directly. They must first be attached to the system directory structure through a process called mounting. In this lecture, we will understand what does mounting and unmounting mean, why they are important, and how we can use Linux command to mount and unmount different file system. Firstly, mounting the file system. Mounting the file system means in Linux, mounting the file system refers to the process of attaching a storage device or file system to a specific directory in the system so that its contents can be accessed. In Linux-based system, and also we can say that Unix-based system, all files and directories are organized in a single hierarchical structure starting from the root directory. When a device such as hard disk, USB drive, or CD-ROM is mounted, it becomes part of this directory structure and user can access the file stored on that device through a mount point. The mount command is used to attach a file system to a directory. The directory where the file system is attached is called the mount point. For example, a USB drive can be mounted to a directory like mnt slash USB using the command mount slash div slash whatever you are putting your directory name slash mnt slash USBs. After the device is mounted, the files stored in the USB drive can be accessed through the slash mnt slash USB. Like in this, we are accessing, we are mounting CD-ROM. That's why we are putting the command and the directory name slash mnt and slash CD-ROM. Without mounting, the system can't read or write data to that device. Different types of file systems such as ext4, VFAT, NTFS, and others can be mounted in Linux. Sometimes the file system type must be specified using the -t option. For example, mount -t slash ext4 div sda slash mnt. The system also maintain a configuration file called etc slash fstb. These are the directories we are mentioning here for the raw file, for the read write, and no directory at a time, USR quota, and group quota. Like these are the things where we mounting all the devices temporarily. If you need to mount a file system, you can use the mount command with the following syntax like mount hyphen t file system type device to mount directory to mount. For example, if you want to mount a CD-ROM to the directory, then firstly, this is the path like slash mnt slash cd-rom. For example, if you write this command mount hyphen t and is of ISO 9660 slash dev slash cd-rom slash mnt slash cd-rom. This assumes that your CD-ROM device is called dev CD-ROM that you want to mount it in slash mnt CD-ROM. Now this is the another mounting, and if you want to mount this device into this directory into slash mnt directory, the mount main page for more specific information or type mount. For that you are using hyphen h at the command line for help information. This file helps automate the mounting process for frequently used storage devices. To detach a file To detach a mounted file system, the unmount command is used. Like, firstly, you see these are the command of mount, like for mounting SDBI to USB, and in this, to mount VFAT to the file system USB, and in this, you also use read and write options. Mount command syntax, this is mentioning here. This is the image where the firstly, if you have a directly, firstly you just whatever want, sorry, whatever your mount point is in this, if you are using in the USB and whatever you are using in CD-ROM and so many other things like maybe sometime hard disk. These are the process of mounting the file system in Linux. For unmounting, you also use this hyphen A options and unmount the device for slash mnt slash USB. Like the main motive of unmounting command is to detach a mounted file system. For example, unmount slash mnt slash USB safely remove the mounted. This command is used to safely remove the mounted device from the directory structure. It is important to unmount a device before removing it physically because removing it without unmounting may lead to data loss or file corruption. The system ensures that all the pending read and write operations are completed before unmounting the device. Mounting file system is an important concept in Linux as well as in Unix because it allows the operating system to manage multiple storage devices in a unified and organized way. It provides users with a convenient method to access data from different devices as if they are a part of the same file structure. Proper use of mounting and unmounting helps maintain system stability, data integrity, and efficient storage management. Now, the next topic is unmounting the file system. Means this is the process of detaching a mounted storage device or file system from the directory structure of the operating system. When a device such as a hard disk partition, USB drive, or CD-ROM is mounted, its contents become accessible through a specific directory called the mount point. This is the command used for unmount the device. Unmounting remove this connection so that the device is no longer accessible through the file system. This process is important when user want to safely remove external storage device or stop using a particular file system. The unmount command is used to unmount a file system in Linux. These are the basic syntax of unmount device. For example, if a USB drive is mounted at slash mnt slash USB, it can be unmount using the unmount slash mnt slash USB. Once the command is executed successfully, the system disconnects the device from the directory structure and the files on that device are no longer accessible through that mount point. It is very important to unmount file system before removing the storage device. If a device is removed while it is still mounted, some data may still be in memory waiting to be written to the disk. This can lead to data corruption, file loss, or damage to the file system. By unmounting the device properly, the operating system ensures that all pending read and write operations are completed in the file system is safely closed. Sometimes a file system can't be unmounted if it is currently being used by a process or if files are open within that directory. In such cases, the system will display an error message indicating that the device is busy. Tools like LSOF, like these are the common options, or Fuser can be used to identify which process is using the file system so that it can be stopped before attempting to unmount again. Like these are the force unmount, -L is lazy unmount, and DV verbose plus detached loop device. After closing the active process, the unmount command can be executed successfully. Like these are the find mounted file system. If you want to find which system is mounted and which is not, firstly you just write the unmount slash f slash mnt hyphen f slash mnt and slash usb command. This command to find out the files mounted file system, like, and these are the type. These have some size, used storage devices, and avail which time is available and whatever the the percentage. Now this is the difference between mount and unmount differences. Like in in the mount, attach mount file system, and for unmount is used for detaching, and we can say that unmounting file system. Connect devices like USB drive and CD-ROMs and hard disk. Now, in this unmount, safely disconnect USB drives, CD-ROMs, and hard disk. Specify mount by point. Like if you want to mount some disk storage, you firstly use some specific points. That is known as some mount point. Unmount is also use some mount point or device. mount is used to create and display file system mounts. Now, moving on the next topic that is known as top command. The top command in Linux is used to display real time information about the running process in the system. You can see this image. This is very useful, and all things are available in this image. It is one of the most important system monitoring tool that helps user and system administrators observe how the CPU, memory, and other memory resources are being used. When the top command is executed, it opens an interactive screen, like it opens interactive screen that continuously updates and shows the list of to process like this, along with their resource consumptions like person ID, user, performance, percentage of CPU performance, and the memory percent of CPU, which kind of CPU is are using, like if you are using some Firefox and some other kind of systems names. When the top command is execute, it open an interactive screen that continuously updated and show the list of active process along with their resource consumption. This makes it very useful for monitoring system performance and identifying the process that are using too many resources. The upper part of the top commands output displays system summary information. This includes details such as system uptime, number of logged in users, CPU usage, memory usage, and load average. It is also shown how much memory is being used and how much is free. These statistics helps user understand the overall health and performance of the system at a glance. The information is updated automatically at regular intervals so that users can monitor changes in real time. The lower section of the top output show a list of running process. Each process is displayed with details such as process ID, username, priority, CPU usage percentage, memory usage, and the command that started the process. By observing this list, user can easily identify which process are consuming the most CPU or memory. This is especially helpful when the troubleshoots slow system performance or detecting unwanted process running in the background. The top command also support interactive commands while it is running. For example, pressing K allow the user to kill a process by entering its person's ID, or we can say that process ID. Pressing Q exit the command. Users can also sort process based on CPU or memory uses to quickly find resource interactive tasks. The basic syntax of top command is just like you just use top hyphen u for username showing process of a specific user, top hyphen p monitor a specific process, top n number of refresh, iterations. These interactive features make the top command a powerful tool for system monitoring and management. The top command is essential utility in Linux system for monitoring activity and performance. It provides real-time information about process, CPU usage, and memory utilization. By using the top commands, users and administrators can analyze system performance, manage running process, and ensure that the system operates efficiently without resource overload. Now we are moving to the next topic. This is the PS command. Like this command is stand for process status, and it is used to display information about active process running in the system. A process referred to a program that is currently being executed by the operating system. The PS command helps users and system administrators monitor systems activity by providing details about running programs. It shows information such as process ID, like we also saying that PID, the user who started the process, CPU time used, and the command that initiated the process. This command is very useful for understanding how processes are functioning within the system. When the PS command is executed without any option, it shows the process associated with the current terminal. The output usually contains columns such as PID, like process ID, TTY, like terminal type, time, cumulative CPU time used, and CMD, the command that started the process. This basic output allows user to quickly check which programs are running in their current working session. It is especially useful when working with multiple programs in the terminal. The PS command offers several important options that provide more detailed information about process. For example, if we write PS-E, this will display all the process currently running in the system, while PS-A show process of all users associated with terminal. PS-F options provide a full format listing that includes additional details such as the parent process ID, like we can also say that PPID, user's ID, and the start time of the process. A commonly used command is PS-E. Like this is the basic command, and we are using PS-E and F, which give detailed list of every process running in the system. Another useful capability of PS command is that it can be combined with other Unix command for advanced process searching and monitoring. For instance, the command PS-E and F, if we are merging these two commands, -e and f, which give detailed list of every process running in the command. It can combine with other Unix command for advanced process searching and monitoring. For instance, the command ps-ef slash script process name allow user to search for a specific process among all the running process. This is very helpful when checking whether a particular application or service is running. System administrators often use this combination to monitor server services and troubleshoot problems. The PS command also helps users identify background and foreground process. Background process run without direct interaction from the user, while foreground process run directly in the terminal. If we write ps-f, this is opening all the active process. And if we type ps aux, this command show all the process in details, like what the terminal time, what is the time, which kind of terminal is this, and which for its directory. By examining the process information displayed by PS, user can determine which programs are active and how they are interacting with the system. This information can be useful when managing multiple applications at the same time. Overall, the PS command is powerful and essential tool for process monitoring in Linux system. It allows users to view detailed information about running process and understand how system resources are being used. By using different options and combining it with other commands, user can effectively manage and monitor process, making the system more organized and efficient. Now we are moving to the next. Like these are the basic structure of ps-f, like showing process ID, parent process ID, what's the time, what is the terminal, which kind of commands in this uh, using. Now these are the description of these commands. Now we are moving to the next command, that is kill command. The kill command in Linux is used to send signals to running process. Most commonly is used to terminate them. In Linux system, every program that is running is called a process and each process is identified by a unique process ID. Sometimes a program may stop responding, run into an error, or consume too many systems resources such as CPU or memory. In such cases, the kill command allows user or system administrator to stop or control that process. It is an important command for managing process and maintaining system stability. The basic syntax of command is kill whatever the process ID name of target process, where PID is the process ID of the program that needs to be terminated. For example, if a process has the ID 3456 and whatever the process ID name, the command kill 3456 will send a single send a signal to stop that process. Usually, the system sends a system and putting hyphen 15, that means this is by default, which politely asks the process to terminate. This allows the process to close files, release resource, and exit safely. The PID of running process can be found using commands such as ps, stop, or pcrypt. The kill command can also send different type of signals to process, not just termination signals. Signals are special messages sent by the operating system to control the behavior of process. For example, SIG stop, like sick term and sick kill, and if and one of the common signal is SIG stop. Pause a process terminally while sick count resume a process paused. These signals allow user to control process without completely stopping them by specifying a signal number or name with the command. Users can change how the process reacts. Sometimes a process does not respond to the normal termination signal. In such situation, a forceful termination can be used with the command kill-p. Process ID, whatever this is the process ID. The hyphen 9 option send the sick kill signal, which immediately stop the process without giving it a chance to clean up resource. While this is very effective, it should be very used carefully because it may lead to data loss or incomplete operation if the program was in the middle of writing data. Another useful feature is that the kill command can be used together with other commands to manage multiple processes. For example, users can find a process using ps and then terminate it using kill. There are also related commands like kill all, which terminate all the process with a specific name instead of using the PID. That means process ID. This makes it easier to stop several instances of the same program at once. Overall, the kill command is an essential process management tool in Linux. It helps user control running process by sending signals such as termination, pause, or resume. By using the kill command effectively, users can manage system resource, stop unresponsive application, and maintain the smooth functioning of the operating system. Like in this image, we are mentioning kill command is killing all the process. If you don't write any process ID, this will kill all. If you want to kill all the process, you use kill all command. Now we are moving to the next topic, performance tools. In the next video, we are studying about the performance tool.